Hello, curious minds, and welcome back to the Science Concept series. In this series, we explore fascinating scientific phenomena in an easy-to-understand way. Today's fascinating concept is the Coriolis effect. You might have heard the term before, perhaps in connection with hurricanes or even draining bathtubs, but what exactly is it, and why is it so powerful? So what is the Coriolis effect? Simply put, it's an apparent force that deflects moving objects like wind and ocean currents when viewed from a rotating frame of reference, such as Earth. It's crucial to understand that the Coriolis effect isn't a true force like gravity or electromagnetism. Instead, it's an apparent force, an illusion created by observing motion on a spinning sphere. Think of it like trying to walk in a straight line on a spinning playground roundabout. You'd feel pushed sideways, even if no one was actually pushing you. The primary cause of the Coriolis effect is Earth's rotation. Our planet spins on its axis, completing one full rotation approximately every 24 hours. Points at the equator are moving much faster than points near the poles. Now let's see the Coriolis effect in action, starting with global wind patterns. The Coriolis effect plays a monumental role in shaping the prevailing winds that circumnavigate our globe. As air moves from high-pressure areas to low-pressure areas, it doesn't travel in a straight line. In the northern hemisphere, the Coriolis effect deflects winds to the right, and in the southern hemisphere, it deflects them to the left. This deflection is crucial. This consistent deflection leads to the formation of distinct global wind belts, such as the famous trade winds near the equator, the westerlies in the mid-latitudes, and the polar easterlies. These wind patterns have profound impacts on climate and human history, enabling exploration and trade for centuries. Beyond the atmosphere, the Coriolis effect also profoundly impacts our oceans, influencing the massive movements of ocean currents. Just like with winds, the Coriolis effect guides the flow of water across vast distances. Warm water from the equator and cold water from the poles are constantly on the move. The Coriolis effect deflects these currents, causing them to curve rather than flow directly. This deflection creates giant, swirling current systems. These large, rotating ocean current systems are known as gyres. The North Atlantic Gyre, for example, includes the Gulf Stream, which brings warm water to Europe, significantly impacting its climate. Without the Coriolis effect, these critical heat-distributing systems wouldn't exist. Perhaps the most dramatic display of the Coriolis effect is in large-scale weather systems, particularly hurricanes and typhoons. This is where the apparent force really shows its power. The Coriolis effect is responsible for the characteristic swirling motion of these massive storms. As air rushes into a low-pressure center, it gets deflected, initiating the rotation. In the northern hemisphere, hurricanes rotate counterclockwise, and in the southern hemisphere they rotate clockwise. This difference in rotation direction is entirely due to the Coriolis effect and the direction of Earth's spin. It's a fundamental principle of atmospheric dynamics that helps us predict and understand these powerful natural phenomena. Before we wrap up, let's address a common misconception about the Coriolis effect, one that often pops up in popular culture. You might have heard the idea that the Coriolis effect determines which way water drains in your toilet or bathtub clockwise in one hemisphere and counterclockwise in the other. While it's a fun thought, this is actually a myth. The Coriolis effect is a large-scale phenomenon, significant only over long distances and durations. On the small scale of a toilet or bathtub, local factors like the shape of the basin, initial water movement, or even vibrations in your plumbing have a far greater impact on the swirl direction. The Coriolis force is simply too weak to be noticeable at that level. So there you have it, the powerful and pervasive Coriolis effect. From steering global winds and ocean currents to orchestrating the spectacular spirals of hurricanes, this apparent force is a fundamental player in how our planet works. It's a beautiful example of how Earth's simple rotation can lead to such complex and far-reaching consequences, shaping our climate, ecosystems, and even human history. Understanding concepts like the Coriolis effect deepens our appreciation for the intricate dance of natural forces around us. I hope this episode has given you a clearer understanding of the Coriolis effect. If you enjoyed it, please give this video a like, subscribe for more science content, and hit the notification bell so you don't miss our next episode.